students, good morning. In this class we can discuss about our last topic of this lesson, that is dimensional analysis. See the screen. Yes, this is the one of the very important topic for our board examination as well as our competitive examination like NEET, JEE. Okay, so listen and watch carefully, students. Let's go with our class. Students, now start our class. Here we can see the first one, that is dimension of physical quantities. Dimension of physical quantities. Already you know one, our physical quantities are classified in two types. One is that fundamental quantity as well as the derived quantities. You know, yes, just you recall what is mean by fundamental quantity or base quantity. What is that? That is the base quantity or fundamental quantity is defined as the quantity which cannot be expressed in any other physical quantity. Yes, correct? Yes, the quantity which cannot be expressed in terms of any other physical quantity, that's called fundamental quantity. Okay, as well as you know that what is mean by derived quantity. Yes, what is the quantity which can be derived from fundamental quantity. Yes, okay. Already also you know one, that is totally 7 fundamental quantities are there. 7 fundamental quantities are there. See the screen. The nature of the physical quantity is described by its dimension. The nature of the physical quantity. Nature of the physical quantity is described by its dimension. That's called dimensional analysis. So ஒரு ஃபிசிக்கல் குவான்டிட்டியுடைய நேச்சரை டிஸ்கிரைப் பண்ணுறதுக்கு யூஸ் பண்ணக்கூடிய ஒரு டேர்ம் தான் டைமென்ஷன்ஸ். ஓகே, see the screen. All the physical quantity can be expressed in terms of 7 base or fundamental quantities. Already you know one. Yes, that is called mass, length, time, electric current, temperature, intensity of light and amount of substance. Okay, this is called fundamental quantity. இதை நம்ம என்ன செய்கிறோம் அப்படின்னா, இட்ஸ் ரைஸ் டு பி டு சம் பவர் டேர்மில் ரெப்ரசன்ட் பண்ணுறோம். ஓகே, தட் இஸ் த டெஃபினிஷன் ஆஃப் அவர் dimensional quantity. The dimensions of physical quantity are the power or exponents. The dimension of physical quantity are the powers to which the fundamental or base quantity are raised to represent that quantity. Okay, are you able to understand? Yes. What is mean by dimension of physical quantity? The dimension of physical quantity are the powers to which the unit or base quantity, to which fundamental or base quantity are raised to represent that quantity. ஸோ அப்போ நம்ம என்ன செய்கிறோம், பவரில் ஆர் எக்ஸ்போனன்ஸ் டேர்ம்ஸை யூஸ் பண்ணி ஃபண்டமெண்டல் ஆர் பேஸ் குவான்டிட்டியை ரெப்ரசன்ட் பண்ணக்கூடிய ஒரு டேர்முக்கு பேர் தான் டைமென்ஷனல் அனாலிசிஸ். எஸ், நார்மலாக டைமென்ஷனல் அனாலிசிஸை நம்ம எப்படி டைமென்ஷனல் எதை யூஸ் பண்ணுறோம் அப்படின்னா, யூஸிங் த ஸ்கொயர் ப்ராக்கெட்ஸ் அரவுண்ட் த குவான்டிட்டி. ஃபார் எக்ஸாம்பிள் லென்த். See the one, some examples are given. Next one, using square brackets around the quantity means like a mass, length, something, anyone. Okay, we are dealing with the dimension of this quantity. So what is fundamental quantity, what is dimension of physical quantity? This is the definition of dimensional quantity. The dimension of physical quantity are the power to which the fundamental quantity are raised to represent that quantity. It will be represented the square bracket around the quantity. Here some examples will be given. See the screen. The dimension of the volume of the object, it's represented L cube. Why sir we can choose L cube? What is L? Length. Already you know the unit of volume. What is the unit of volume? That is meter cube. The meter is the fundamental quantity. Okay, see the screen. That is length is one of the fundamental quantity. It will be taken as a capital L. Meter represented capital L, meter cube. Then we'll write cube symbol. Another one is that dimension of force will be given. What is that? That is ml square mlt power minus 2 mlt power minus 2. Okay, it's how can it come? Because it is come from the unit of SI unit of force, you know one. What is the SI unit of force? That is Newton is the SI unit of force. Yes, already you know one. It will be equivalent unit for Newton is, what is that? That is kilogram meter second power minus 2. How it's come from? It is derived from Newton's second law. F is equal to ma. Yes, F is equal to ma. What is the unit of mass? That is kilogram. What is the unit of acceleration? A. That is meter second power minus 2. Okay, ஸோ அதைத்தான் நம்ம சேர்த்து இங்கே என்ன எழுதுறோம்னா ஃபோர்ஸோட டைமென்ஷனல் ஃபார்முலாவாக எழுதுகிறோம். ml t power minus 2. Okay, and another one is the dimension of energy also given. Energy nothing but work done, that is force into distance. Okay, see the last one. That's all. So in this slide we discussed about what is fundamental quantity, what is dimensional analysis, then what is the dimension of physical quantity. Another one, yeah, how to it represented. It will be used as a square bracket, and some example will be given. Okay, that's all. Next we can see the dimensional formula and the equation. Students, next here we can see the classification of dimensional quantity. Classification of dimensional quantity. Once again we can see that what is mean by dimensional quantity, then that classification of dimensional quantity. See the screen. First here we can see that what is dimensional quantity. So dimensional quantity is a physical quantity which has dimension. அப்போ எந்த ஒரு ஃபிசிக்கல் குவான்டிட்டிக்கும் டைமென்ஷனோட சொன்னோம்னா அதுக்கு குவான்டிட்டிக்கு பேர் என்ன? டைமென்ஷனல் குவான்டிட்டி. ஸோ வாட் இஸ் டைமென்ஷனல்? அப்போ எந்த ஒரு பேஸ் குவான்டிட்டியும் பவர் டேர்மில் ரைஸ் பண்ணி சொல்கிறதுக்கு பேர் தான் நம்ம என்ன சொல்கிறோம்? டைமென்ஷனல் குவான்டிட்டிஸ். ஓகே, ஃபார் எக்ஸாம்பிள் சம் எக்ஸாம்பிள்ஸ் வில் பி given, that is speed, nothing but velocity, acceleration, momentum, torque, etc. So all physical quantity almost have same dimensional quantity. Okay, next one, what is the dimensionless quantity? Dimensionless quantity. அப்போ இது அப்படி ரிவர்ஸில் சொன்னோம்னா dimensionless quantity. What is that? The dimensionless quantity is physical quantity which has no dimension. Underline the word in your textbook. The physical quantity which have no dimension but have variable values are called dimensional variables or dimensional quantity. Yes, underline the word. The dimensionless quantity, the physical quantity which has no dimension. In this case which has dimension, that's called dimensional quantity. This is dimensionless quantity. For example, relative density, refractive index, strain, almost all ratios will be dimensionless quantity because both unit will be same. Automatically it will be cancelled to each other. Okay, in case of how it will be represented, for example we take refractive index. The definition of refractive index is the ratio of velocity of light in air medium to medium. Velocity of light in air to medium. So here both the unit of velocity will be same. So denominator and numerator both unit will be same. Automatically cancel the unit. So refractive index has no dimensional quantity, dimensionless quantity. Yes, next one. See the next one. That is dimensional constant. Next we can see the dimensional constant. What is dimensional constant? Dimensional constant is the constant which has dimension. Dimensional constant is the constant which has dimension. So some example constants ku dimensional values irukum. For example, see the screen, like a universal gravitational constant. What is that? That is capital G. We are using Newton's law of gravitation. Already you know, you have studied your 10th standard Newton's law of gravitation. In the universe, the force between two object, ரெண்டு ஆப்ஜெக்ட் இடையில் இருக்கக்கூடிய ஃபோர்ஸை சொல்லக்கூடியதான் நியூட்டன்ஸ் லா ஆஃப் கிராவிடேஷன். இந்த ப்ரொபோஷனாலிட்டி கட் பண்ணுறதுக்காக யூஸ் பண்ணக்கூடிய ஒரு யூனிட் கான்ஸ்டன்ட் டைம் தான் கேபிட்டல் ஜி. எஸ். நெக்ஸ்ட் ஒன் யுவர் ஃபெமிலியர் ஒன், தட் இஸ் பிளாங்க்ஸ் கான்ஸ்டன்ட். It's also dimensional constant, Hubble constant. It will be used for astronomical unit. Okay. Then Stephen constant, that is K. Wien's constant, Boltzmann constant, universal gas constant. Already you studied your 10th standard, capital R. Yes. Faraday constant, etc. Okay. That's called dimensional constant. And the last one, dimensionless constant. The dimensionless constant which has no dimension, like a pi value 3.14 or 22/7, it has dimensionless constant. And charge of electron, it's like a dimensionless constant. So dimensional quantity, it will be classified in 4 types. One is a dimensionless quantity, dimensional constant, and dimensionless constant. Any one of these topic is 2 mark question. Any one of this one 2 mark question for our board examination, as well as are you able to understand? Yes. As well as 1 mark questions also taken from this topic. Okay. Next we can see that some dimensional formula for some physical quantity. It's a very important topic, students, so listen carefully. Before we go to dimensional formula, you can see the dimensional formula and dimensional equation. That is dimensional formula and dimensional equation. Okay, see the screen. The expression which, how and which of the base quantity represent the dimension of physical quantity, it's called dimensional formula. The expression which shows how and which the base quantity represent the dimension of physical quantity. அப்போ ஒரு எக்ஸ்பிரஷன் ஷோ பண்ணுது, எப்படி ஒரு பேஸ் குவான்டிட்டியை எப்படி டைமென்ஷனலாக நம்ம எக்ஸ்பிரஸ் பண்ணியிருக்கோம்னு சொல்கிறதுக்கு பேர் தான் டைமென்ஷனல் ஃபார்முலா. ஓகே, see the some example for dimensional formula. For example, volume, the dimensional formula for volume, that is m l t, m power 0 l cube t power 0. Totally, in case of dimensional formula, using the first 3 base quantities only, we are using first 3 base quantity, like a mass, length and time. Okay, for m power 0, anything power 0, you know one, the value of anything power 0 is 1. So m power 0 is 1. And l cube, what is l cube? It's a dimensional formula for volume. It's derived from the unit of volume is meter. That meter, it will be converted into dimensional formula using the letter capital L power 3. And another one is a unit of time, you know one, that is second. The dimension of time is capital T. So here t power 0 is given. You know the value of anything power 0, that is 1. So the dimensional formula for volume is m power 0 l cube t power 0. Okay, so another one is the dimensional formula for speed or velocity. The dimensional formula for speed or velocity. Okay, you know the definition for velocity already. I think you studied your 10th standard, 10th or 9th, 8th. Okay, so what is velocity? It's nothing but the definition of velocity is the rate of change of displacement or displacement by time taken. That's called velocity. What is displacement? It is represent, the unit is meter. What is the unit of time? Second. So the unit of velocity or speed is meter second power minus 1. Yes, good. So it will be converted into dimensional formula. It is write as a lt power 1, because the length, the dimensional formula for length is L, and time, it is represented T. So meter L and time T. So LT power minus 1 is the velocity, the dimensional formula for velocity. And the last one, what is acceleration? The rate of change of velocity, it's called acceleration. Rate of change of velocity, it's called acceleration. That is, it is denoted the letter small a. Okay, a is equal to L, a is equal to v by t is the expression for acceleration. V by t. What is v? Velocity by time. Okay, already you know the unit of velocity, meter second power minus 1 again divided by second. So ms power minus 2. So dimensional formula is lt power minus 2. M power 0, lt power minus 2. Okay, this is the some example for dimensional formula. Some example for dimensional formula. In case of what is dimensional equations, the equation obtained by equating physical quantity with its dimensional formula, it's called dimensional equation of the physical quantity. An equation obtained by equating physical quantity. So physical quantity வச்சு equate பண்ணி ஒரு ஈக்குவேஷனை நம்ம கொண்டு வரோம் அப்படின்னா இது அது இல்லாமல் எது வித் ஹெல்ப் ஆஃப் டைமென்ஷனல் ஃபார்முலா. டைமென்ஷனல் ஃபார்முலா வச்சு ஒரு ஈக்குவேஷன் ஃபார்ம் பண்ணோம்னா அந்த ஈக்குவேஷனுக்கு தான் என்ன நேம்னா டைமென்ஷனல் ஈக்குவேஷன். எஸ், see the some example. You know how to write the dimensional formula, that is square bracket, using square bracket. The quantity is v is the one of the derived quantity, velocity. The dimensional formula for velocity is volume, that is capital V is the volume of the volume. Then the dimensional formula of the volume is, dimensional equation or dimensional formula is m power 0 L cube t power 0. Yes, another one velocity and acceleration. Okay, that's all. So in this slide we can discuss about what is dimensional formula and dimensional equations. Okay, that's all. Next we are going to some dimensional formula for some physical quantity, one of the important. Okay, so listen carefully students. Next we can see the dimensional formula for some physical quantity. It's one of the important topic. Okay, so listen carefully students, because this dimensional formula is very must for your board examination. கண்டிப்பாக நம்மளுடைய போர்டு எக்ஸாமினேஷனில் ஒரு 1 மார்க் கொஸ்டினில் எக்ஸ்பெக்ட் பண்ணலாம். அதே நேரத்தில் நம்மளுடைய நீட் எக்ஸாமினேஷனுக்கும் ஒரு இம்பார்ட்டன்ட் டாபிக். ஓகே, ஸோ கண்டிப்பாக நமக்கு ஈஸியாக டைமென்ஷனல் ஃபார்முலா உங்கள் மெமரியில் இருக்கணும். ஸோ லிசன் கேர்ஃபுல்லி ஸ்டூடெண்ட்ஸ். ஓகே, see the first one, the physical quantity, that is length is given. The symbol of length is, dimensional symbol is capital L. Okay, it's one of the fundamental quantity. Already you know one, length is the fundamental quantity. The unit of length you know one is meter. Okay, the dimensional formula is, how to write the dimensional formula? We are using the square bracket of the physical quantity. Okay, so L only are there. So L, another term m power 0. Already you know one, anything power 0 is 1. So m power 0 and t power 0. So L is the dimensional formula for length. Yes, see the next one, that is mass. Already you know one of the mass is the fundamental quantity. The unit of mass is kilogram. Yes, good. This unit of mass is kilogram. Okay, so the symbol of mass represented at capital M. Okay, so capital M available, L not available, so L power 0 and t power 0. So 1 into 1, here 1. So only M is the dimensional formula for mass. Another one base quantity will be given, that is time. See the third one, that is time. It will be represented the letter capital T. Okay, it's one of the fundamental quantity. The SI unit of time is second. Yes, so here the symbol of time represents the capital T. So only m power 0 and L power 0 and t is the dimensional formula for time. Next we are using, it's a derived quantity. Area is the derived quantity because it will be derived from the base quantity of length. Length ல இருந்தா நம்ம ஏரியாங்கிற derived quantity கொண்டு வரோம். ஓகே, You know the formula for area. What is that? That is length into breadth. Here represent the letter is L into B. Okay. Already you are familiar one. Area of the square or area of the rectangle, anything. You know the area of the area means that is length into breadth. Okay. It will be represent the letter like a capital A. Capital A. That is area. That is the dimensional formula for area. So how to write? That is the dimensional formula for length is L. So one L, another one breadth also measure the unit is meter. Okay, so also another one L. So the dimensional formula for area is L square. So m power 0 L square t power 0. L square is the dimensional formula for area. The unit of area already you know one. What is that? Meter square. Length into breadth. Okay, meter into meter, meter square. Just you multiply by height, it will be converted area, it will be converted into volume. So area into height, it's known as volume. Area into height is known as volume. So just you multiply by another one L, it will be the unit is converted into L cube. So already you know one, the dimensional formula for volume is L cube. The unit of volume is meter cube. Okay, next one, linear density. Linear density. Yes, what is linear density? Mass by length. Mass by length. The symbol of linear density represents the letter lambda. Already you know one Greek alphabet, one of the Greek alphabet, lambda. We are using wavelength or maximum we are using wavelength, represent the letter is lambda. Okay, so lambda is the linear density. The definition or formula for linear density is mass by length. The definition of or formula for linear density is that mass by length. Okay, what is the dimensional formula for mass? M. And what is the by? It will be represented inverse. What is the dimensional formula for length? It is L. So M by L or M L inverse. Okay. The unit of linear density is kilogram meter inverse. Kilogram meter inverse. Okay, students. Go to the next one. See the next one, that is mass density. Already you are familiar one. Normally we say density. Okay, it is represent the letter is rho. That's called density. So the density, the formula for density is mass by volume. Mass by volume. The dimensional formula for mass density or density is L power minus 3 m L power minus 3. Why, sir? The dimensional formula for mass is capital M and the dimensional formula for volume L cube. So M capital M by L cube or m L power minus 3. The unit of mass density is kilogram meter power minus 3. Okay. Another one densities are there, that is surface density. What is surface density? Again same, mass by area. Mass by area. So what is the unit of surface density? Our dimensional unit is m L power minus 2. Just you write your textbook, surface density. Surface density. Okay. In our textbook, the table number 1.1 will be given by some another quantity. Here we can discuss some other quantities. Okay, don't confuse. Okay, students, see the next one. What is that? It is one of the dimensionless variable like a specific gravity or relative density. Specific gravity or relative density, because both density terms, so automatically the unit will be cancelled. So it is a dimensionless variables. Good. Next one is that specific volume, that is 1 by reciprocal of density, it's called specific volume. 1 by density, nothing but reciprocal of density. Reciprocal of density, that is mass density. Appo volume by mass, it's called specific volume. Okay, the dimensional unit is, dimensional formula is L cube m inverse. L cube m inverse. Next one is the time period. What is time period? One of the fundamental quantity, that is capital T. Time taken for one oscillation. The unit of time period is second. The dimensional formula for time period is capital T. See the screen. Okay students, and the last one is the frequency. What is that? That is represent the letter is nu, not V. It is nu. Okay, the reciprocal of time period, it's called frequency. It's a very very important one. Already you study your 10th standard in, I think, 5th lesson, acoustics lesson. You are using frequency, wavelength. Yes, just you recall. Okay students, so the formula for frequency is reciprocal of time period, it's called frequency. The unit of frequency is second inverse. The SI unit of frequency is hertz. Okay, hertz is the SI unit of frequency. The dimensional formula for frequency is T power minus 1 or T inverse. Okay, that's all. This is the some general physical quantity, the dimensional formula for some general physical quantity. Okay, that's all. We can see the next one. Students, next again we can see the dimensional formula for some physical quantity in terms of mechanics. We are using mechanical physical quantity like a distance, displacement, wavelength, focal length, anything. எந்த இடத்துலலாம் லென்த்னு வருதோ அந்த இடத்துல பூரா நம்ம என்ன டைமென்ஷனல் ஃபார்முலான்னு எதை யூஸ் பண்ணிக்கலாம்? கேபிட்டல் எல்லை யூஸ் பண்ணலாம். ஓகே, இட்ஸ் எ கிவன். சி த ஸ்க்ரீன். Distance, displacement, wavelength, focal length. Already you have studied your 10th standard focal length. So the dimensional formula for this type of physical quantity is capital L. The unit is meter. Okay, so what is the difference between speed and velocity? Speed and velocity. See the screen. Both unit will be same, meter second inverse, as well as the dimensional formula also same, but definition will be changed or formula will be changed. See the screen. Speed represent the letter is V, but definition is distance by time. And velocity represent the same letter, that is V, but displacement by time. What is the difference between both these two quantity? This is the scalar quantity. Speed is the scalar quantity. Distance, what is the distance? Students, what is the distance? How to define the distance? But the distance is defined as the actual path length traveled by the object. Just you write your textbook. What is the distance? The actual path length. For example, or object travel from one path, one point to another point. அப்போ அந்த ஒன் பாயிண்ட்டுக்கும் அனதர் பாயிண்ட்டுக்கு இடையில் இருக்கக்கூடிய அந்த லென்த்தை தான் நம்ம என்ன சொல்கிறோம்னா டிஸ்டன்ஸ். தட்ஸ் கால்ட் distance. Okay, are you able to understand? Yes, good. That is called distance. Okay, the actual path length traveled by the object in a given interval time, it's called distance. Okay, it's a scalar quantity. Just you write your textbook, distance is the scalar quantity, because it's a very important quantity. It is a very important one. Okay, so what is next one? That is displacement. Displacement almost the same answer. No, displacement has direction. Displacement என்ன இருக்குன்னா சேம் டெஃபினிஷன் தான், பட் ஒரு பர்டிகுலர் டைரெக்ஷனில் மூவ் ஆகுது. சேம் கான்செப்ட், ஒரு ஆக்சுவல் பாத்து தான். அப்போ அந்த பாத்து எப்படி வேணாலும் இருக்கலாம், அந்த ஆப்ஜெக்டை அந்த பாத்தில் எப்படி வேணாலும் போயிட்டு அந்த பிளேஸை ரீச் பண்ணலாம். அட் த சேம் டைம் ஒரு பர்டிகுலர் டைரெக்ஷன், இந்த டைரெக்ஷனில் தான் போகணும் அப்படின்னு நம்ம சொன்னோம் அப்படின்னா அதை தான் நம்ம என்ன சொல்லலாம்? டிஸ்பிளேஸ்மெண்ட் அப்படின்னு சொல்லலாம். ஃபார் எக்ஸாம்பிள், சிம்பிளாக நம்ம அண்டர்ஸ்டூட் பண்ணணும், டிஸ்டன்ஸையும் டிஸ்பிளேஸ்மெண்ட்டையும் அண்டர்ஸ்டூட் பண்ணணும்னா சிம்பிள் எக்ஸாம்பிள். ஏதாவது ஒரு ஊருக்கு ஒரே ஒரு ரூட்டு மட்டும் கிடையாது, மெனி ரூட்ஸ் இருக்கும். ஒவ்வொரு ரூட்டுக்கு தகுந்த மாதிரி டிஸ்டன்ஸ் மாறும். பர்டிகுலராக இந்த மெயின் ரூட், இந்த ரூட்டில் போனோம் இல்லை சீக்கிரம் போயிடலாம். இந்த பர்டிகுலர் ரூட்டை நம்ம மென்ஷன் பண்ணால் அது டிஸ்பிளேஸ்மெண்ட். ஸோ ஸ்டார்டிங் பாயிண்ட், எண்டிங் பாயிண்ட், பர்டிகுலர் டைரெக்ஷன், தட்ஸ் கால் டிஸ்பிளேஸ்மெண்ட். Distance, what is distance? Starting point, ending point same, but direction is different. எந்த direction வேணாலும் போய்க்கலாம், but reaching point same. That is distance. Okay? So this is the difference between distance and displacement. Distance, the speed is the scalar quantity or magnitude of velocity. Just you write your textbook, speed is the magnitude of velocity. Okay? What is velocity? The definition of velocity is displacement by time taken. Okay, so this is the difference between speed and velocity. Okay, next one, see the screen, that is velocity gradient. What is velocity gradient? You are familiar one. Here you are see many times d by dt, dv by dt, anything by dt. So அந்த dt னு நம்ம சொல்லும் பொழுது என்ன சொல்லுவோம்னா ரேட் ஆஃப் சேஞ்ச் ஆஃப். யூ ஆர் யூஸிங் த டேர்ம் இஸ் ரேட் ஆஃப் சேஞ்ச் ஆஃப். பட் கிரேடியன்ட் மீன்ஸ் டிஸ்பிளேஸ்மெண்ட்டை பொறுத்து வெலாசிட்டி சேஞ்ச் ஆகுது. எனி குவான்டிட்டி சேஞ்சிங் வித் ரெஸ்பெக்ட் டு டிஸ்பிளேஸ்மெண்ட், தட்ஸ் கால்ட் கிரேடியன்ட். ரைட் யுவர் டெக்ஸ்ட் புக். ஓகே, எனி குவான்டிட்டி சேஞ்சிங் வித் ரெஸ்பெக்ட் டு distance or displacement, that's called gradient. So here the quantity, physical quantity changing. What is the physical quantity here? Velocity. Velocity changing with respect to displacement, it's called velocity gradient. So velocity gradient nothing but time inverse. What is that? That is frequency second inverse. Okay, t inverse. Okay, how sir? Already you know the formula for velocity, lt power minus 1 by t. ஸோ டி அப்போ டி மேலே வந்துடும், எல்டி பவர் மைனஸ் 1. ஸோ அதை நம்ம யூஸ் பண்ணி நம்ம இங்கே கொண்டு வரலாம். நெக்ஸ்ட் ஒன், வாட் இஸ் தட்? ஆக்சலரேஷன் ஆர் ஆக்சலரேஷன் டியூ டு கிராவிட்டி. போத் குவான்டிட்டி வில் பி சேம். ஆக்சலரேஷன், the rate of change of velocity, that's called acceleration. Same concept but due to gravity, that's called acceleration due to gravity. The unit of acceleration or acceleration due to gravity, meter second power minus 1. This is the dimensional formula for acceleration due to gravity or acceleration, lt power minus 2. Another one, physical quantity, very familiar one, that is momentum. Momentum, nothing but the definition already you are familiar one, mass into velocity. Its represent the letter is capital P. Okay, capital P. So the unit is kilogram meter second inverse is the unit of momentum. The dimensional formula is kg, capital represent the capital M, meter represent the capital L, second also represent the T inverse. So MLT inverse. Another one is that force. The formula force is derived from Newton's second law, mass into acceleration. It is the represent the letter is capital F. Okay, here see the screen, that is m l t power minus 2 is the dimensional formula for force. It is the kg meter second power minus 2 is the derived unit of force. Derived unit of force, and SI unit of force is Newton. How to write Newton? Small n e w t o n, Newton. It is the symbol is capital N. And another one is the force constant or spring constant. It is derived from some laws, Hooke's law, etc. So force constant represent the letter is K. The unit of force constant is Newton meter inverse. Force per length, that's called force constant. And last one, impulse. Impulse nothing but force. It is represent the letter is J, small j. The formula is force into time. Force into time. The dimensional formula of impulse is mlt power minus 1. The unit is Newton second or kilogram meter second inverse. It's a very important, students, both dimensional formula as well as unit. Okay, as well as you very கண்டிப்பாக இதோட ஃபார்முலா தெரிஞ்சால் தான் நம்ம ஈஸியாக டைமென்ஷனல் ஃபார்முலா எழுத முடியும். ஸோ ஜஸ்ட் யூ மெமரைஸ் திஸ் formula. Okay, that's all. See the next one, students. See the next one, that is again we can see the some dimensional formula for physical quantity. Here we can see the dimensional formula for mechanical quantity like a work, energy, energy density, power, pressure head. Okay, see the screen. First you can see the mechanical quantity like a work. That is the symbol of work, that is represent the letter W. Okay, the formula for work is force into displacement. Force into displacement. Work nothing but energy. Work nothing but energy. Okay, so the dimensional formula for work is ml square t power minus 2. The unit of work is kilogram meter square second power minus 2. The SI unit of work done is joule. Both energy also, the unit of energy also joule. Okay, see the definition of energy. See the definition of energy, that is capacity to do work. Capacity to do work. The represent the letter is capital E. See the screen, the work and the energy has same dimension, ml square t power minus 2. Okay, see the next one, that is energy density. That is energy density, energy per volume is the formula for energy density. The unit is joule meter power minus 3. The dimensional formula for energy density ml square t power minus 2 divided by L power L cube. ஸோ அதை நம்ம சிம்பிளிஃபை பண்ண வர்ற யூனிட் தான் ml inverse t power minus 2. Next one is the power. Power nothing but energy by time. Okay, ஸோ அப்போ ஒர்க், எனர்ஜி, பவர் மூணுமே ஒரே குவான்டிட்டி, ஆல்மோஸ்ட் சேம் தான். அப்போ ஒர்க் பை டைம். What is the dimensional formula for work? ml square t power minus 2 by again another one t. Simplify, we get ml square t power minus 3. Okay, next one is the pressure. It's also familiar one. Force per area. Force per area. The SI unit of pressure is Pascal. The derived unit for pressure is Newton meter power minus 2. The dimensional formula for pressure is ml inverse t power minus 2. And the last one, pressure head, that is nothing but meter, so that is L is the dimensional formula. Next, we are using the dimensional formula for some gravitational concept. First here we can see the gravitational potential, that is gravitational potential energy per mass, that called gravitational potential. Joule per kilogram is the unit. The dimensional formula is m power 0 L square t power minus 2. It's derived from using gravitational potential energy unit. Okay, next already you know one gravitational constant, that is dimensional constant. It is the formula is derived from Newton's law of gravitation. Okay, so the dimensional formula for gravitational constant is a very important one, m inverse L cube t power minus 2. It's derived from using this formula. G is equal to F into D square by m1 m2. The unit of gravitational constant is Newton meter square kilogram power minus 2. And the last one is the intensity of gravitational constant, gravitational force per mass. Gravitational force per mass, nothing but the unit is m power 0 L inverse L t power minus 2. The unit is Newton kilogram inverse. Okay students, that's all. Next we can see the another one. Students, next we can see the last topic of today's class. Okay, in this topic is not your textbook. just you write your textbook or any other note. Okay, see the screen, students, it's a very important one. Here, see the screen, quantity have the same dimensional formula. Quantity having the same dimensional formula, it will be used for our 1 mark questions. So very very important, just you write your textbook. Okay, impulse and momentum. Impulse and momentum having a both same dimensional formula. Just you write your textbook, impulse and momentum, it's a same dimensional formula. And work, energy, torque. Torque nothing but the force of rotational motion. எப்படி ஒரு லீனியர் மோஷனை நம்ம ஃபோர்ஸ் நம்ம சொல்கிறோமோ, அதே மாதிரி ரொட்டேஷனல் மோஷனில் டார்க் நம்ம சொல்லலாம். ஓகே, அண்டு மொமெண்ட் ஆஃப் ஃபோர்ஸ். Both 4 quantities are having same dimensional formula. Third one, angular momentum, Planck's constant, rotational impulse. Okay, angular momentum nothing but rotational momentum. இப்போ மொமெண்டம்ங்கிறது லீனியரில் சொல்கிறது. angular momentum it will be represented letter L, mvr. Okay, Planck's constant and rotational impulse. These 3 quantities also having same dimensional formula. And stress, pressure, modulus elasticity, energy density, this quantity also having a same dimensional formula. Force constant, surface tension, surface energy, this quantity also having a same dimensional formula. Angular velocity, frequency, velocity gradient. இப்போ நம்ம ஃப்ரீக்வன்சிக்கும் வெலாசிட்டி கிரேடியண்ட்டுக்கு சேம் டைமென்ஷனல் ஃபார்முலாங்கிறது லாஸ்ட் ஸ்லைடில் கூட பார்த்தோம். Another one, angular velocity, it will be represented with the letter omega. This also having a same dimensional formula. And gravitational potential, latent heat, thermal capacity, entropy, universal gas constant and Boltzmann constant, force, thrust, power, luminous flux. This is the same dimensional formulas இருக்கக்கூடிய physical quantity. Okay, just your textbook, just வீடியோ பாஸ் பண்ணிவிட்டு இந்த கொடுத்துருக்கூடிய இந்த குவான்டிட்டியை ஜஸ்ட்டு எழுதிக்கிங்க. கண்டிப்பாக நம்ம இதிலேருந்து 1 மார்க் எக்ஸ்பெக்ட் பண்ணலாம். ஓகே, தட்ஸ் ஆல். டுடேஸ் கிளாஸ் கெட்ஸ் ஓவர், ஸ்டூடெண்ட்ஸ். இன் அவர் ஹோம்ஒர்க் இஸ் ஜஸ்ட் யூ ப்ராக்டிஸ் டேபிள் நம்பர் 1.11 in our textbook, page number 31. Just you practice the physical quantity expression and unit and dimensional formula. கண்டிப்பாக அது நீங்கள் மெமரியில் இருந்து தான் ஆகணும். ஸோ ஜஸ்ட் யூ ப்ராக்டிஸ் இன் யுவர் ஹோம். ஓகே, ஆஃப்டர் லேர்னிங் திஸ் டாபிக் just you write your home test. Okay students, that's all. Thank you.